Welcome back to another video. On this video, we're going to learn how to name angles, but we're also going to look at a couple special types of angles, and that's adjacent, vertical, complementary, and supplementary. So here we go. All right, naming angles. Back in the day, hopefully you learned that you could have a line that goes on forever and ever. You could have a line segment that had two endpoints. Or you could have something called a ray. An array has an endpoint and goes on forever in one direction only. So what we're looking today at is angles. And what an angle is an angle is two rays sharing an endpoint. And that endpoint has a very special name. It is called vertex. So the vertex is where the two endpoints meet. It's basically like the corner of the angle. The vertex is where two rays meet. Okay. We're going to look at a couple real quick ones here. Ones you've probably seen before. If you're going to do a 90-degree angle, that's usually like the perfect corner of your paper. Very important to note, if it doesn't have a square in there, the square indicates it's 90 degrees. If there's no square, you can't assume it's 90 degrees. You have to actually know, because it could be something like 89.9 degrees, which is not 90. All right, 180 degrees is also called a straight angle, and that's your rotational turn halfway around. So if you're facing one direction, a 180 turns you backwards. And then a 360 is a full and complete circle. And angles. Angles are not measured in length, but they are measured in the amount of degrees that you spin in a circle. So it's more of a circular measurement. And there's a couple ways to name angles, and it is this. You will always use 3 letters to name your angle if there are multiple angles in your picture. The vertex must be the middle number. Again, when there's multiple, the middle letter. Wow, there's a typo there. When there's multiple angles, the vertex has to be your middle letter. And this little thing here is the symbol in geometry for angle. So instead of writing the word angle, whatever it is, I'm going to be using that symbol in the place of the word angle. So let's take a look over here. If we had a bunch of angles over here, A, B, C, D, and E. If I told you, would you please measure angle B for me? You might be confused. Do I mean the angle that goes here to here? Do I mean the angle here to here? Do I mean the angle here to here? Maybe I mean from here all the way to over there. Who knows? I mean, well, I don't. So that is why you have to use 3 letters. So here we go. Let's try a few. If I wanted to name this angle right here, where the arc is, that one could be angle ABC, or it could be angle CBA. But notice either way, the B, the vertex, is the middle letter, and that's the way it has to be. The vertex is always your middle letter. If I wanted to talk about this angle here with a double arc, I could call it angle CBD, or I could call it angle DBC. Again, notice the vertex is that middle letter. If there's only one angle in the picture, you can just name it, and here's what that would look like. If you had L, M, and N, what you'll see is sometimes it will have a number inside. If that's the case, you could call this one angle 1. If it's the only angle there, you could call it angle M by the vertex only, or you could call it with its 3-letter names, which would be angle LMN or NML. So that's how you name an angle, and there they are. So now getting into the different types of angles, there are something called adjacent angles. And adjacent angles, adjacent just means next to. So that's the key word here. Adjacent is next to. And adjacent angles, they share a side and they share a vertex. So I'll show you what we mean. We have these angles here. There's angle 1, 2, 3, and 4 highlighted here for you. And what we're going to do is name all the adjacent angles. So let's say we start here at angle 1. Angle 1 is adjacent to or next to angle 2. Notice that they have the same vertex. They share a vertex, but they also share a side. This is the side they both share. Angle 2 is made up of this side and this side. Angle 1 is that side and that side. Notice that side makes up both angles. They are adjacent next to. But angle 2 is also adjacent to another angle here. Angle 2 is next to angle 3. And angle 3 is also next to another angle, and that's angle 4. And you may see where I'm going with this one. Angle 4 also has an adjacent angle, and that's angle 1. So those are our adjacent angles, and that just means next to. The next type is vertical angles, and for these ones, we have across from. And what that means is they're going to share a vertex. They're both going to have that little pointy corner that touches, and it's the same pointy corner for both of them. So they have that vertex, but they don't share a side. So they have to have separate sides, but they have the same vertex. And so in a case like this, what we have here is, if you look at all our angles again, angle 1 is across from angle 3. Notice this one is across from this one. And notice they don't share a side. Those are the sides for 3. Those are the sides for 1. They don't share them. Also, we have angle 2 is vertical angle with angle 4. That's this one and this one. So we've got those ones are their vertical ones. Something that's really special about vertical angles, because of the way they're formed, they are equal in measure. And then we can use that to find unknowns. For example, to find an x, if we can see that two angles are vertical, then we know they have to be equal in size. So we can actually write an equation like that. We have x plus 16 equals 4x minus 5. Like I said, these two have to be equal. So in my equation, I set them equal to each other. And I go through and solve. I'm going to start by subtracting 1x from both sides, leaving me with 16 equals 3x minus 5. Here's my side with my variable. So I've got a two-step equation. I'm going to add 5 to both sides. It's 21 equals 3x. And this cancels out to be 0. And then the last step, divide both sides by 3. And we get that our x value is 7. One thing you want to pay attention to, sometimes they just say solve for x. We did it, we're done. Sometimes they ask, how big is the angle? Well, you can substitute 7 into either one. This one looks easier to me. If I put 7 plus 16, I get 23 degrees. So this angle is 23 degrees. I could also substitute 7 into this one, but guess what? It's the same size as that one. So this one also has to be 23. So there it is, verticals equal in size. All right, and then we come to complementary angles. Complementary angles are two angles that add up to 90 degrees. And in this case, the angles can be together, they can be separate. There's all kinds of ways they can be shown. For example, over here, these two angles, one is 60 degrees, one is 30 degrees. If I add 60 plus 30, I get 90 degrees. Whoa, little mistake there. And 90 degrees means it's complementary. Notice the ones down here. Let's see if we can zoom in a little. One of the angles is 40, one of them is 50. Again, if we add 40 plus 50, you get 90 degrees. So these two here are also a right angle, also known as complementary. If you hear banging in the background, the cat's trying to get in the room. Notice my square here indicates the right angle as well. Again, if we have angles with x's in it, we can say, you know what? These two together should add up to 90 because they form together a right angle. There it is, that box. So I could say here, 3x plus 2 plus the x plus 4 equals 90. This one plus that one equals 90 degrees. And then I'm going to combine like terms and solve my problem. Here's 3x and here's 1x. That's really 4x. So might as well simplify that there. Here I have a plus 2 and a plus 4. That's really just plus 6. So once I'm done with that, I go ahead and solve. I'm going to subtract 6 from both sides. And that gives me 4x equals 84. And then last step, divide both sides by 4. And we get 21. Okay. Notice the value of x here is 21. That doesn't mean that's how big each of these angles are. This one here would be 21 plus 4 or 25 degrees. And then you could either do 90 degrees minus 25 to find the other, or you could substitute 21 into this, multiply by 3, add 2, and find its measure. And our last one, we've got supplementary. And supplementary just means two angles that add up to 180 degrees. And so for these ones, again, it can be two separate angles. It can be angles that are connected. One special other kind of vocabulary here is a linear pair. If you've got two angles that make a straight line along the edge, like here and here, then you have a linear pair. Their outsides together make a straight line, and that's 180 degrees. So those would also be called supplementary or a linear pair. So if we look back here, we've got this one. If I add 60 plus 120, I end up with 180 degrees. Therefore, these ones are supplementary. Down here, I don't know if you can see the marks, but it says 130 degrees plus the other 50 degrees that are there. Those add up to 180. So another example of supplementary angles. All right, and we can use that to our advantage once again to write equations out. I notice that this angle here, the 3x, and this angle here, the 54 degrees, make a straight line on this side together. So that means they are a 180 degree angle or straight angle. And so what I could say is that 3x plus 54, this one plus that one, has to equal a total of 180. And so with that done, we can go ahead and solve our equation. So we're going to start out by subtracting 54 to both sides. And we get 3x equals 126. And then last step here, we're going to divide both sides by 3. And we get x equals 42. And so that is the value for x in this one, supplementary and complementary. I do have one little trick for you to help you remember complementary and supplementary. If you notice the word complementary has one P in it, supplementary has two P's. The P's to me look like backwards 9s. So complementary is 90 degrees, just one of the 9s. Supplementary is another 90 and 90, or 180. The one with the two P's is bigger. The one with the one P is smaller. And again, those are 90 and 180. Another student once showed me this one as well. If you add a slash sideways, complementary, or the letter C turns into a 9. If you add a slash on the supplementary, the S, you get an 8 for 90 and 180. So, whoa, that's a 0. So those are some of the ways to help you remember the difference between complementary and supplementary. And that is it for today. Thank you guys. Bye.